So good evening everyone. So this is the last week of the course Data Science for Engineers, week 8. So yes, good evening. So today we'll look at the week 8 assignment of the previous course, and later I will just discuss with you some other algorithms also for classification. So we'll move on with the presentation. So this week, okay, the people are still joining. So this week you have learned about clustering using k-means clustering, and then also classification using k-nearest neighbors. So based on that, the assignments are formulated. So we'll look at the first question. So in this one, so I'll just shift to the presentation mode. So here the first thing given is consider the data set usrs.csv and answer the questions from 1 to 4 based on the information given below. Okay, so I'll just give an information about the data set given. This might also be the data set given in your present assignment also. So the data set contains statistics in arrests per 100,000 or 1 lakh, residents for assault, rape and murder in each of the 50 US states in 1973. Also given is the percent of population living in urban areas. So these are the variables given: states, murder, assault, urban population and rape, and description about the data is also given. So first thing is we have to set the column states as index of the data frame while reading the data. Then set the random number generator to set.seed 123. Normalize the data using scale function and build the k-means algorithm with the given conditions. So number of clusters is equal to 4 and n start equal to 20. So these are the things given, the steps to be carried out. So we'll move on to the RStudio. So here you can see that I have given the first question. So for this is optional. You can just first set the the working directory if it's not in the current present table, but right now for me the working directory contains the data set. So I will just show you the data set also. So the data set looks like this. Okay, this is the data set: states, murder, assault, urban population and rape. Like this one data set is given. So using that data set you have to do the necessary analysis. So yes, so for this purpose, the libraries that we have to install is caret as well as class, so that we can install first. Now if it's not already installed, you might have to install it using this thing: install.packages caret dependencies equal to true. Also if class is not installed, that also you have to install using the install.packages class dependencies equal to true. This you have to do. Then according to the built model, the first question is, according to the built model, the within cluster sum of squares for each cluster is, that is asked first. Okay, so in our question what was asked is that first we have to set the column states as index of the data frame while reading the data, and later we have to set the random number generator to set.seed 123. So first that we'll do. So data equal to read.csv usrs.csv. So header equal to true we are giving, because we want to make the header is already present in the data, and then we want to make the state's name as the index. Sorry, is everyone having voice problem? Okay. So Rohit, I think you can log out and log in once again. Okay. Yeah, so we were saying, like, first we can read the data. So, okay. I think, yeah, okay. Yeah, so we have to read the data, and usrs.csv, okay. This is the data. Okay. So I'll do like this, usrs.csv and I have read this to data. So right now you can, I'll just clear the environment once again and all the things. So okay, so first you have to read the data, and then after that the required thing is random number. Then normalize the data using scale function and build the k-means algorithm with the given condition, number of clusters equal to 4 and n start equal to 20. So for that, any doubts? Okay, so you have to scale the data and you have to set the random seed. So first thing, I'll be scaling the data using the scale function. So df equal to scale of data, that is okay. Then I'm setting the seed so that it will be reproducible the next time also. Now we are using the k-means clustering and the data is df. Then the number of clusters we are giving as 4 and n start equal to 20. Okay, so this is the k-means clustering that we have to do. So we have normalized the data using scale function and we are building the k-means algorithm. So the first question is, according to the built model, the within cluster sum of squares for each cluster is, you have to find it out. Okay, the within cluster sum of squares. Okay, so we'll fit the data. So fit equal to k-means of df, centers equal to 4, n start equal to 20. Okay, and just we have to give, so fit right now has the k-means clustered values. So if you take fit, you can see the cluster, centers, many other data is given. Okay, so first the question is like to find the within sum of squares. So we can just give fit dollar within ss. Okay, so just if you run this one, you can find out the within cluster sum of squares is 8.316061. like this you can find it out. Okay, so for more clarity, I will just go to this link and okay, so the k-means parameters and result. Using this, I'll just explain the different parameters present. So usually if you give a particular value with k-means, like the data, all these things if you give, so these are the arguments that are present in that particular function. So iteration is dot max is the maximum number of time the algorithm is done, is run. So usually you won't give any value for this one. Then n start will represent the number of random data sets used to run the algorithm. So for example, if you want 3 clusters and if you are specifying n start equal to 10, then it extracts 3 sets of data 10 times. Okay, so your final cluster will be there, you'll be having 3 clusters, but for getting this 3 clusters, first it will extract 3 sets of data and 10 times, and for each of these 10 times the algorithm is run for the maximum iterations which is given. Okay, and the cost function will be evaluated so that the lowest is chosen as the result. So this is what is usually happening in the k-means clustering. So I'll come back to the RStudio. So when we have given within some squares of the fit model, we got the result as this one. So the answer will be A right now. Okay, I hope it is clear till now. If required, I will just explain it once more. So the answer will be this one. Is everyone, those who are having a laptop and RStudio can work this out right now. If you want, I can load the data. Okay. Yeah, so this random number thing will be generated, I mean, in most of the algorithms, right? You have seen it before also, right? Okay, I'll explain once more. So the data which is given for us is usrs.csv. Okay, so the variables and description is given right now. So variables given are state, murder, assault, urban population and rape, and description is like where the incident occurred, the number of arrests for murder, number of arrests for assault, then percentage of urban population there, and the rape arrests. Okay, so all this is for 100 per 100,000 residents. So I think one person has raised a hand. If you want to ask a question, you can ask, or maybe wait till I explain it once more. Centers is okay, I think you have, okay, I'll come to that. Okay, I'll come to that. So I'll just first explain the problem once more. So set the column state as index of the data frame while reading the data. These are the things that we have to do. Set the random number generator to set.seed 123. Normalize the data using scale function and build the k-means algorithm with the given conditions. These are the data which is given. So I think I had opened this. This is the particular data set that we are looking at. The states are given, so it is a categorical column. Murder, the number of murders, so these are all numbers. Okay, so it is like a value, continuous value. So this one is like categorical, but the cardinality will be high, meaning like the number of categories will be like, I mean, how many states are there, all those states are given. Okay, so you can't tell like this much category is repeating this much times, that you can't say. Okay, so only one occurrence per state is there. So this is the data. Now if you go to the RStudio, wait a moment. If you go to the RStudio, okay, you can load the necessary libraries. So first you have to read the data. One of the things given is that header equal to true. That means that your data already has the header present. You can see here in the data, the header is already named. Okay, there are labels for the header like states, murder. So a header is present for the data. So that's why you are giving header equal to true. Then row dot names equal to state, because it was given like you have to make the index as the state names. So that's also done. So when we read this one, it is asking for the data and the data looks like this. So right now we have the row names, row indexes as the state names. Okay, and the different other sets of data are present. Now we have to scale the data. Scale the data means, I'll show you what happens then. So you can see when we scale the data, initially it was looking like this, 13.2, 10 like that. Okay, when you scale, the mean and variance of each of the mean and standard deviation like x minus mu by sigma usually will be done. Okay, so your data will be normalized and given. Okay, so here the earlier data, the initial data was looking like this. When you have scaled it, it came in this way. The data came in this way. Why is it done is that this particular algorithm which we are doing is like, so you are forming clusters, right? So the clusters, the distance between the clusters and all is taken for this particular type of algorithm, right? The Euclidean distance and all, even for the KNN classification also. So in these type of algorithms, if one of your columns is having a higher magnitude, that also will be taken in the training phase. That also will be given some priority. So that priority with the magnitude of the data which is given have to be avoided. That's why you will be scaling your data before you will be training this particular algorithm. So for that, so you every time you have to scale the data for this kind of algorithms. Now set.c. So this one is usually present in all of the algorithms. You will be setting this because in every cases you will be seeing some case where like you have to, your algorithm will be looking at different functions, different states of a random function. Okay, so like if your function is running in a particular state, it will be producing a particular output. Okay, so this random value generator, it's like a random array will be generated every time. Okay, for every, so even for the algorithms that we had seen before for the logistic regression and all, there also we had seen this set.seed. Okay, so why is that? This particular method, this random number generation, is present in all of the algorithms. It is necessary. Okay, so because we will be starting with a random function, we'll be starting with a random number, because first we don't know which is the initial point to start with, right? So every time we will be starting with a random number. So the random number will be given by a random function generator, and this random function generator will be given a particular seed value. This seed value will decide at which state it has to start with. Yeah, the algorithm will work, but have you tried to run it another time? Is the same answer coming? Hariom, who was that? Yeah, Hariom, have you done it many times? And have you tried it with a very big data set? Okay, so what happens is that, first time when you run the algorithm, it will be starting with a particular random number. Okay, next time the same random number won't be generated if you are not specifying it. If you are not specifying the state, some other number will be generated, and it will be starting from that value. So sometimes when you look at the final accuracy, even if you are not setting the seed value, sometimes the answer will be coming okay. But when your data is having a lot of variation, and when your data is very much a very big data set and all, with so many relations, like so many features, then there will be variability in the answers that you're getting. So to prevent that and to set the variation with respect to the random number generation, you will be setting the seed. Okay, so I hope that is clear. Hariom. Okay, so just wait a moment. Many people are still joining. Okay, so what was the other question? So I'll continue this one. So we have just scaled the data and stored it to DF, and we are setting the seed as 123. So any value you can give. If you set the value as 1 also, that is fine. So right now in the question we are asked to set it like set the random number generator to set.seed 123. Okay, now fit k-means df centers equal to 4 and start equal to 20. So for this I have shown you the thing here. Okay, so I'll just share this link to you also. So this is the normal k-means function, and different other things are present. So iter.max, that is like iterations, maximum iterations. So it is like the number of iterations that you have to give the function, or how many times it has to iterate. Okay, so that is fine. Then n start will represent the number of random data sets used to run the algorithm. Okay, so for example, at the end you want 3 clusters. Now in our question it's like at the end we want 4 clusters. Okay, number of clusters is 4. Now, and for example, if the n start value is 10, then just wait a moment, n start is 10, then then it extracts 3 sets of data. So it will start with 3 sets of data, but these 3 sets of data will also be taken 10 times. Okay, and each of these times the algorithm is run up to a maximum of number of iterations given. So you can see here in the above example, 10 times 50 will be coming. Okay, so 10 times 3 sets of data are taken, and the iterations are given as 50, because here you see iter.max equal to given as 50. So in this particular case the cost function is evaluated like 500 times, because there are 10 sets of data. Initial n start is given as 10, and each of these 10 times 3 sets of data are taken, and this whole process is repeated for 50 iterations. So you will have 500 calculations of the cost function. Okay, so who was that? Yeah, so Nagababu, so the centers, cluster centers is 4 and n start is 20. So it's like 4 sets of data will be taken 20 times. It's not like 4 into 20. You'll be starting with 4 sets of data. Okay, because anyway you want at the end 4 clusters. So initial starting points, 4 points will be taken, and this thing itself will be extracted 10 times, and then this whole process will be done for a number of iterations which is given. Okay, yes. So then after that So you have set the seed. I think I have run till now, till that, and then you are fitting the k-means model. So fit is like a list of 9. So you can see cluster here, then centers. So it will be like 4 centers are the cluster centers are there, and with that the total sum of squares, within sum of squares, total of within sum of squares, between sum of squares, everything you will be getting in this model. So we will see each one by one, because the first question was within cluster sum of squares for each cluster. So here you can see, just for getting that you can give fit dollar within sum of squares. Okay, so the answer will be the first option. First option you will be getting. Is it clear for everyone now? Okay, so just for like telling this one, you can see that, I mean, here in this particular case you will be having, this is just a thing, okay, so you will be having 4 clusters. For example, I mean, I am making a very clear demarcation in this thing, but real data will not be like this, okay. So I'll just put it in different colors. So these are 4 clusters, okay. So right now 4 clusters are present, and in this one, first right now you have found out the within cluster sum of squares. So you might be finding, some cluster points in all this data, and in between that point the cluster sum of squares within cluster. So that means inside the cluster sum of squares you have found out. Okay, next question is, so this is the answer, this is how you have to do. Next one, according to the built model, the size of each cluster, so wait a moment, according to the built model, the size of each cluster is, the order of values in each option could be different, so it is given. So we have to find the size of each cluster. So this is also, you just can look at the fit. Yeah, answer is given. Hariom has given C. Okay, so that is true. So just you can just print fit dollar size, or you can go to the fit and see the size. It's given 8, 13, 16 and 13. Okay, so just I will run that one, so you can see this one, and your answer is the third one. Okay, so answer is C. Then the between cluster sum of squares value of built k-means model is, so in this case, so now we have seen the within cluster sum of squares. Now they are asking the between cluster. So between region is here, okay, this is the between region. So between cluster sum of squares is asked. So for between sum of squares also you can look at the fit, it is written clearly, this one, yes. So either that, or you can just type this and you will get 139.5968. So the fourth question is, total sum of squares value of the built k-means model is, so sum of squares, the total value of that is 196. This also you can look at the fit and see. total sum of squares like this one, or you can just type this value. Okay, so I hope the first question is clear. Not the first question, I mean the first connected question till 1 to 4. Okay, so I hope all are clear with the answers. The detailed answers is also given in the PPT. If any doubts, you can ask now. Okay, I hope it's okay. So which of the statement is incorrect about the KNN algorithm? The answer is given there. So first I'll read the first one. KNN works only for binary classification problems. That is incorrect, because you can have multi-label classification also with KNN. Now if k equal to 1, then the algorithm is simply called the nearest neighbor algorithm. That is true. If k equal to 1, you can call it the nearest neighbor algorithm. But in case if the k is 1, it will usually lead to overfitting. Okay, that also is one other problem. Usually you won't give k equal to 1 because it is very computationally time complex also, because it will take like simply put, it will take so much time for calculation also. Not like if you are giving a very small data set, that doesn't matter, and k equal to 1 also will be giving the same answer also. But in case if your data set is large, like maybe even if it is having like 500 entries or so, then also it will be like having so much time for computation. Then the number of neighbors k will influence the classification output. That I think in the lectures also you have seen. Here also we will be having an example to see how it will influence. So as the number of neighbors, you have to set an optimum number of k to get an optimum value or a higher value of accuracy, and to get higher classification, I mean better classification parameters. So the first thing is incorrect, because KNN works for multi-label classification problems as well. All right, I think that's a direct question. Now k-means clustering algorithm clusters the data points based on, okay, answer is given there, distance between the point and a cluster center. So k-means clustering classifies variables based on the distance between the point and a cluster center. So first you will be starting with, if your k is 3, then 3 cluster centers will be there, and then you will be finding out the distances between the points with that cluster, and then finally you will be reaching at final number of clusters. Okay. Now the method or metric which is not useful to determine the optimal number of clusters in an unsupervised clustering algorithms is, can you tell me? Okay, C, A, some are giving A. Okay, so the answer is A, that is right. Okay, so it is asked not useful. Okay, so you can see that method used to determine optimal number of clusters in unsupervised clustering algorithms are either dendrogram or elbow method. Okay, this you can research later on, I mean find out more later on. Scatter plot is not used. It can be used to see the distribution of the data. It's not useful is A, Ujjwal. Answer is A. It's asked like which method or metric is not useful. So the answer is actually scatter plot. Okay, because both the other things are used for determining the optimal number of clusters. Scatter plot is just used for seeing the distribution of the data at the initial state. Whenever you are first given with a data set, you can see how the features are distributed in a particular data set For that you can see this scatter plot. Alright. Correlation between features you can see from the graph, that is okay if it is showing a particular relation or a linear shape, okay, but correlation mostly will be seen by either using the ggplot or directly you can find the correlation. Okay, you can infer from the plot that you can do, but the values will be obtained directly if you use a correlation function. Okay. So you can usually use the ggplot, actually a pair plot you can use actually, so that because that will be showing all the features, relationship between all the features and the distribution of the features also. So you can see for a pair plot that I have discussed in the previous lecture, you can see how the data is distributed for the different number of samples as well as its relation between the other features. If there is any correlation between the features present in the data set also you can find, because at the end when you are training, your features which are inside your data set shouldn't have any correlation between them. If you are having some correlation between the data sets, then you should avoid that particular feature and you can go for the training. Correlation in between the features is not advised. Okay, so that is answer is A. The unsupervised learning algorithm which aims to partition n observation into k clusters in which each observation belongs to the cluster with the nearest centroid is A, B, C, D, any one of them. Okay, B. Yes. Okay, so answer is B. The k-means algorithm identifies k number of centroids and then allocates every data point to the nearest cluster while keeping the centroids as small as possible. Okay. Now some practice questions. The most commonly used distance metric to calculate distance between centroid of each cluster and data point in k-means algorithm is A, B, C, D. Okay, that's right, Euclidean distance. K-means clustering classification variables classifies variables based on. Okay, that is true, distance between points and a cluster center. Which of the following statement is not true about KNN algorithm? Okay, explicit training and testing phases are involved while implementing KNN. Okay. Then scaling is important in distance based algorithms because this we have seen, that's why we have scaled it first. The reason for it. Okay. Shekhar, you have given D or? Srinath has given A. Okay, then both A and B. Okay, wait. So what you can say is like, usually what you will calculate, variables with higher magnitude will influence the results more, that you can say. Okay. Yeah. Now, which of the following is true with respect to k-means clustering? I think I have drawn this before. Okay, I am getting answers A as well as B. Okay, the inter-cluster distance and intra-cluster distance. So just for clarification, if you have two clusters like this, okay, different points are there, okay, three clusters are there, okay. The intercluster distance is the distance between two clusters, okay, and intra-cluster distance is how big the cluster is within the cluster, okay. So okay, I'm getting answers B. B is like intercluster distance is maximized and intra-cluster distance is minimized. That is true. We will always be looking for maximizing the distance between the clusters. Different clusters would be having very clear demarcation, and also the cluster distance should be maximized, and within the cluster also the intra-cluster distance should be minimized, okay. So the intercluster distance is maximized and intra-cluster distance minimized. Any doubts in this one? Those who have given other options? Okay, I hope there are no doubts, okay. So we'll move on to the RStudio. So we have seen one particular data set, okay, and fit, etc. So what we'll do is we'll see last class I had discussed about some other algorithms also. We will see the R implementation today. So before that, we have seen k-means clustering in our assignments. We look for the classification also, KNN classification also. So for that, I have taken the same example from last week. This is the iris example, okay. So I don't have the data set here, but it's already present in the data is already present in RStudio, so it's okay. So I'll just install the libraries required, and we'll be looking at the iris data set. So here you can see the data set is like looking like this, okay. So sepal length, sepal width, petal length, petal width, and species. So right, you can see that species is the 5th column. It's already coming as a factor with 3 levels, okay. So then the head also I have printed, that means the first 6 values of the data set. So you know that last class I have given the description about the data set. So it is like 3 classes of a particular flower and the different petal and sepal lengths of this particular thing. So this data set contains 50 classes, 50 entries of each of the different classes. 3 different classes are present. So the first 50 is like Setosa, the next 50 will be Versicolor, and the last 50 will be Virginica. This is the data set last time we have seen. So first we will be splitting the data into train and test. So split equal to sample dot split. The data to be splitted is iris with the split ratio 70% training set and 30% test set, okay. So I have splitted it, and I am giving wherever the split is coming as true, I am giving in the train class, and the other one I am giving in the test class, okay. So train and test. So right now I clicked test, and this is the train set, okay. So train set have all 3 data, as well as test set also has all 3 classes, okay. So it is done. Now the next thing is feature scaling. So here in feature scaling, we will be separately scaling the data. So train scale equal to scale train CL 1 to 4, test scale test CL 1 to 4, okay. So why are we doing 1 to 4? Because from columns 1 to 4 only the features are present, and the fifth column is the target. Okay, so I hope that's clear. Now can you tell me if can we do the scaling before the splitting? What is your idea about that? So right now in this particular example, I have just splitted it first into train and set, and then I am scaling it. Okay, this is like a question usually coming in data science thing. So okay, people are telling yes. Any different answers? But not for test set. Okay, Nagababu is telling like you can do for train but not for test. Others are telling like you can. Okay, just listen to me. I think I will just. Okay, so here you can see that, for example, I have, so right now this is the iris data set we are seeing. Okay, I hope this screen is visible. So iris data set total, it has 150 observations, and in that we have just now splitted 70% as test and 30% as train. Sorry, this 70% as train and 30% as test. Okay, so okay, first we will go with scenario 1. Scenario 1 is like I will scale the data first and then I'll go for splitting. Okay, so scale means if you are doing the scaling first, so I am doing this like x minus mu by sigma. Okay, that I am doing for all the columns. So x is the data in that particular column, mu is the mean, and sigma standard deviation. Okay, so if this thing I'll be applying across all columns. All columns means the first one is sepal length, I'll just denote it by L, sepal width, petal length and petal width. So for each of the column I'll be calculating the mu, then standard deviation, and for each of the data I'll be giving x minus mu by sigma. Okay, so here in this case, if I am doing the scaling first, the number of observations will be like 150. Okay, and the mean will be calculated like the sum of the observations by 150, right? So this happens across all the columns. Okay, so first when I am doing scaling, the scaling will be taken across all the data. Okay, so the scaling will be done across all the rows of the data, and then after doing the scaling, we'll be going for the splitting. Okay, so here what happens is that the data set which we are giving as test also is changed. That means it's not the pure data set. In usual data science or machine learning problems, why are you using the test set? The test set is taken as a representative of data which the model has not seen yet. Okay, so the model has not seen it once. That is what the test set is represented as. We are taking the test set from the same data, but its representation is like whenever you are getting a new data, then it should directly classify or predict it using the new data which is coming. So when we are doing the scaling first, it's no longer a new data. It has been changed according to some of the variations that we are doing. Is it clear? Now the scenario 2. In the scenario 2, what we are doing is like first we are splitting. Okay, first we are splitting. Splitting means So 70% as train and 30% as test. Okay, so what we are doing is like, first we will scale the train set. Okay, so like for example 70% of this one will be like 105 observations, right? So 105 observations, and from this one we are normalizing. So the mean and standard deviation will be coming for 105. Now according to that we will be scaling it, and then what we will be doing is that we have found out the mu and sigma values from these 105 observations, and later we will be applying the same mu and sigma to the test set. We are not changing anything. Whatever operation we have done for train set, we are just doing that operation for test set, because anyway we have to do some operations, because we can't have just the train set scaled and the test set not scaled. That is anyway not possible, because when you are finally training the model and after that when you are predicting, your data has seen a data which is like scaled, which is having particular values between like 0 to 1 only. Okay, so test set also should be in that format, but it's not necessary that the data should be taken from the test set also. Okay, so that is why we need a test set which has not been done any changes with respect to the data taken from it. Okay, when we are first scaling the whole data, we are considering the values in the test set also while calculation. Now when we are splitting the train and test set first, the test set is completely kept pure, and then only we are applying that transformation. Okay, so is it clear? Is it clear, or any other question? Okay, so that's why we are going like that. Okay, so in this case for feature scaling we can do like this. Okay, in R, in those of you who have done in Python, you might have seen like scale, fit transform and transform, right? This is a particular, the same method, similar method which is used in Python. So there you will be taking the train set first, and you will be doing a fit transform where you will fit according to the mu and sigma, and then you will be transforming it. And for the test set you will only be doing a transformation which was obtained from the train set. Okay, so that is in the Python case. So now we have scaled it, so we have obtained the test scale as well as the train scale. Okay, now next what we will be doing, next what we will be doing is we have to train the data. So the train is like train scale, test is like test scale, then CL is train underscore scale $species, because that is what we are classifying. Okay, for the different species, and we are first giving k equal to 1 because that it's the nearest neighbor that we are classifying, that we are using first. So we will see what it gives. So classifier underscore knn has given this particular data for all the values. Now we will see the confusion matrix to see how efficient it is. So table, we are using a table here. Last time also you have seen two different methods of calculating the confusion matrix. So right now I am using table. Test underscore CL is, we have splitted it across like this. Okay, so that is the initial one, $species, so it is like untouched, the species is there, and like classifier underscore knn will have the different classifiers, and I'll just do that, and this is the table. So you can see here classifier underscore knn is our knn, the values which are obtained from the classification, and this one is the original one. So you can see here 20, 19, 17, are coming as the diagonals. Okay, so setosa, this is okay, true, positive, like that. And in between, so here you can see 3 values are coming, which are like given as virginica, but it's usually versicolor, like that. Another thing also has come like 1. So when you are calculating the accuracy in this particular thing, you have to see the principal, this diagonal, main diagonal, and you have to add the sum of this diagonal elements, 20 plus 19 plus 17, by the total number will give you the accuracy. So that itself we will see here. So another way of calculating it is like, first you can find the misclassification error. So mean of classifier underscore KNN, so that is our prediction, not equal to test underscore CL dollar species. So we are seeing the instances where these two are not equal, and that is added, and that mean is found out. So then this misclassification error will be taken like that, and 1 minus that misclassification error will give you the accuracy. This is another method for finding it out. So accuracy will be coming like 0.933, that means 93.33%. Okay, so that's how you have found out the classification accuracy for k equal to 1. Now you can see, I mean, we have just told now for different values of k, there is a chance that your accuracy will change. We will see that right now. So again, I am giving classifier underscore KNN the same arguments, but just I am changing k equal to 3. So when I run this particular thing using the same statements as earlier, the classification accuracy comes as 95% for k equal to 3. Okay, so it has improved when k value has increased. Okay, now k equal to 5, we are seeing the nearest neighbors we are considering as 5 nearest neighbors. Okay, so now we will see the misclassification error and the accuracy. Again, it is coming like 0.95, that means 95%. So for k equal to 3 as well as 5, the accuracy had come as 95%. Now classifier underscore kn with the same things repeating for k equal to 7, and 7 also gives 95%. We'll see 15 how it looks like. So 15 again goes down. For 15 it comes like 91.67. okay, so we had got 95% for k equal to 7, k equal to 5 as well as k equal to 3. So you can have a higher accuracy with k equal to 3 itself in this particular case. Now we'll see again anyway for k equal to 19 also, and 19 again it comes like 93.33. okay, so we'll usually what we'll do is like for optimization, when we are optimizing the parameters and also when we are running this KNN algorithm, we'll first plot k values with respect to the accuracy. For what value of k you are getting higher accuracy, that we'll be seeing, and wherever the optimum accuracy is coming, that particular k value we will be taking. Okay, so later you can look at these references for KNN classifier in R programming. Okay, so I have given some references that you can see. So I think KNN classifiers are clear for you. Any doubts you can ask. Okay, I hope there are no doubts. So what we will be doing is like we'll look at SVM now. Okay, so we have seen k-means clustering. Okay, then KNN classification also seen. we have seen. So I think before SVM, first we look at k-means for the same data set. For IRIS data set itself, we'll use k-means clustering. Okay, it's not required, but we'll see how you can do it. Okay, because the IRIS data set is usually used for classification problem, but in your case k-means clustering we'll be seeing how it performs. Okay, so you know that k-means clustering, it is an unsupervised nonlinear algorithm, right? And it is a cluster based data based on similarity or similar groups. Okay, so right now the data set which we have taken is IRIS data set. So this IRIS data set is having like 3 classes. Okay, it is a supervised problem. Okay, your data set has petal length, petal width, sepal length and sepal width, and also it has labels also as different 3 classes. So usually you just want to use any classification algorithm only, but since we have learned the k-means clustering also, we will see how to implement that here. So k-means clustering is unsupervised, so you don't need the labels which are given in the IRIS data set. So we'll see how to do that. So data, it's loaded in as IRIS. Okay, and this is the data set, it has the different classes. Okay, so moving on, just seeing the structure also. Earlier we haven't looked at it, but these are numerical values for the first 4 columns, and the fifth column is like a factor with 3 levels: Setosa, Versicolor and Virginica. Okay, now for these things some packages are required. So if it's not installed first, you will have to install that, but if it's already installed, you have to first load that much only is required. So anyway, I have installed it also. Now just wait a moment. Okay, set of questions PPT I have shared already in the Google Drive. Rohit, haven't you seen that? Yes, in Google Drive. Okay, I can show you that, I think. If you go, wait a moment, it's loading. Paper pattern, what you have given instruction given to you only, that also we'll be knowing. Okay, since we are the TAs, so there will be a set of things. Okay, I think mail has been given to you. I think this is not loading, please wait. Okay, just wait. The SWIME set is not opening right now. Okay, what can I do? I will just put the drive link. Okay, my PPT, everything is visible, right? I think I have some net problem here. Just a confirmation if I'm audible. Okay, yeah, So it's right now not coming for me. Wait a moment. Okay, I'll share the link. Yeah, I think someone has already shared it. Okay, you can check this link. There every week's videos as well as the drive link is visible. Okay. Okay, sorry for inconvenience. So I think it's there. Okay, so yeah, Sai Venkat, just wait a moment, I'll just check that. I think there was a mail sent for exam format. Okay, so it's given for all the courses actually. There was a list, and in that list your particular course was given, and for that the exam format was given, right? So it is like for this one, online and computer based exam will be there, and for that it will include multiple choice questions, fill in the blanks, essay type answers, etc. Computer based exam, right? Yours is computer based exam, Rohit. So it has to be entered on the computer. Negative marking, that you have to see. Okay, the exam, I'm not sure of that, might be there. You won't get RStudio. RStudio won't be usually there. That was the case which was usually observed. Okay, you don't have RStudio. Okay, so we were in this right now. So we have installed library for cluster R and for cluster. Okay, now what we'll see that use is like since this is an unsupervised nonlinear algorithm, what we'll be doing is like iris_1 we'll be giving like iris minus the label. Okay, because we don't want the label here right now. So what we'll be doing is we'll be removing that label and giving in iris1. So iris1, you can see just the 4 columns which has petal length, sepal width, petal length and petal width are present. We have removed the label. Then fitting k-means clustering model. So seed, I am giving a different seed right now. Then k-means result, I am just giving for iris1. Cluster centers, I am just putting as 3 because we already know that it will be like clustered like 3. And then n start equal to 20. Then k-means we have just typing it here, so you can see the different cluster means for sepal length, sepal width, petal length and petal width. Okay, for the different clusters, these are the means. Then the vectors, clustering vectors, then within cluster sum of squares, everything is given. Okay, now cluster identification for, does anyone want to speak something? Okay, so k-means.re $cluster will give you how it has been clustered as. Okay, so that is done. Then again the confusion matrix as a table I am doing, and when I plot it, we'll be getting it like this. So 50 Setosa, versicolor and virginica is given. Now what we'll see, we'll do the model evaluation and visualization. So in that, first we will be plotting sepal length and sepal width, then with the cluster. Okay, so first plot, you can see here, this is the plot. Okay, sepal width with respect to the sepal length. Okay, now then we will see how it is seen with the cluster. Okay, so this one, if you check, this is how it has been clustered with. So right now we have just taken sepal width as well as sepal length only. This is marked with black, then red and green. These are the different classes. This is the distribution. Okay, so after that, next what we'll be doing is, so we have seen the distribution, we have seen how it has been clustered. Now we want to know where the different clusters are given. So right now in the same plot, what we'll be doing is like we'll be plotting the same thing, and then we'll be seeing the centers. Okay, so right now k-means with 3 clusters are plotted. I'll just zoom it out first. So here you can see that this is the 3 clusters. Okay, now k-means dot centers, this one when we are giving, these are the different centers for sepal length and sepal width. Earlier we have seen the means for this different things. So now we are seeing how the centers look like with respect to the sepal length and sepal width. Now we have found out the centers for k-mean. Now what we'll be doing is we'll be plotting these centers in the same plot. So I'll close the plot right now, and then okay, wait, once again the plot, and then I'll be seeing the centers. So here we have already plotted the, so I'll zoom it out. So okay, so this is the plot, you can see the plot here. Now after that, just we have given it here like k-means dot re dollar centers we have stored for sepal length and sepal width, and now after that we have given points k-means dot re centers, sepal length and sepal width also we have added in the graph. Then here it is written, I mean last class you had already asked it, CEX is the font size, PCH is the symbol. So with that we have marked the cluster center also. So in this black cluster, the cluster center is here. Actually we have already seen the values also earlier. Then this one is the red cluster and the cluster center for that particular cluster, and the green one mark is the cluster center for that particular cluster. Okay, so that is done. Then visualizing the cluster, the same thing, cluster plot we'll be doing, and we'll be seeing that cluster. So just wait a moment, the plot is there. So the clusters are given and their values are also plotted. Okay, so it's like kind of overlap right now with the different values of the plots. So here also we have taken between sepal length and sepal width, and the different clusters and their values are just plotted here. Okay, so for more details you can go to this particular link. So here what we have seen, we have just removed the label first and then we have clustered it again. Okay, so just we will see what happens when if you give it as 4. Okay, we will see. So if you give it as 4, now also some clusters are formed. Okay, and if we see the confusion matrix, it's coming like this. Okay, but doesn't, I mean there is no particular we can't infer it out, because in this particular species only 3 are present. So if we are clustering it as 4, there is no particular meaning to it, but just for the observation we will just see how it looks like. So here you can see, when we give the clusters as 4, this is one cluster. This is actually very much pretty differentiated from the other one, because last time also when we had looked at the iris data set, you have seen that sepal length has a particular normal distribution, and you have seen the significance also, right? So you had already found out that those have particular significance. So that's why you can see this particular thing, there is one particular class which is very much different from the other classes. So that's why we are getting the green like this. Okay, now the other classes you can see it's intertwined between the other clusters. Okay, so it's difficult to cluster them, right? So now if since we have given as cluster is equal to 4, it has formed like this, but that doesn't have any meaning, right? Because we already know it's a supervised problem only. We already have the labels as 3 classes, right? So that's anyway the k-means cluster thing. Now later, next thing we'll look at SVM. All right, so because last class I had talked about support vector machine, so again we will just see the thing. Okay, because last class I have discussed how it is, so now also we'll just see how the algorithm is like. So support vector machine, the basic idea is like you will be having groups, the points on either side according to homogeneous relationship, we'll be grouping them using a line known as a hyperplane. Last class also we have seen this. So these set of points can be easily demarcated with the help of a hyperplane. Okay, and last class we have seen how to plot the support vectors from that particular hyperplane, and we had seen when the dimensionality is increased, sometimes in some cases if this particular reading is like this, for example your distribution of the data is like this, you can just change it to a higher dimension and then you can demarcate the data, differentiate the data. So that is how the support vector machine works like. So you will have to find a hyperplane. So finding the hyperplane has many different methods. Okay, so that is like you will be using a kernel. So this kernel has like different types, actually linear, radial basis, different types are there. So based on the kernel your data will be separated by a hyperplane. Okay, so that is support vector. So what we'll be doing is like we'll be taking one particular data set. So necessary plots for that I'll be importing, like caret, ggplot, ggalley and ggpubr. These are all for plotting actually packages. Then caret you have already seen, right? Caret is used for classification. It's known as classification and regression training package, that is already there. This one psych, that is usually provides like various physiological data analysis it is used for. Then reshape you have already seen. So all these packages I'll be loading. Okay, then different versions are coming. Okay, so what I'll do is that for this particular data I'll be using this particular diabetes data set. This diabetes data set is usually used, it's a data set which is given by UCI machine learning repository, and there are many methods by which you can get that data set. Okay, it's originally from UCI machine learning repository, but right now you can go to Kaggle also. So in Kaggle you can see this particular database, and this data set is originally from National Institute of Diabetes and Digestive and Kidney Diseases. Okay, for that particular thing, okay, runtime, cost or efficiency, you have to go for many different theories behind that. Okay, Bishwas, you can search for that. Okay, cost efficiency, I mean how many operations are done. Okay, that is a very different topic. Okay, so it's kind of a vast topic also, how to find out the computational complexity, so that you can just search later. Okay, so this is the particular data set, and the data is like, you can download it and use it. Okay, so I have just read it and downloaded it and stored. Okay, so this is stored as diabetes.csv. Just I'll show that data. It looks like this. Okay, so number of pregnancies, glucose values, blood pressure, skin thickness, insulin values, BMI, diabetes pedigree function, age, and outcome. So this is this particular data set. It is like predicting whether that person has diabetes or not based on these all values. Okay, so this is like taken for PIMA in females. Okay, so in that data set you had seen. So I have just loaded it as DF. So here you can see this is the data set, and all these numeric values are present, and outcome also right now it has taken us numerically. Okay, because it is 1 or 0. 1 denotes diabetes, 0 is like no diabetes. Okay, now there are 768 observations of 9 variables total. 9 total columns are there now. So that is your particular data set. If you do a head of that particular data set, this is what is coming. Okay, now sum, to check if there is any null values in our data set, first what you have to do is .na of df, and if you do a sum of that, you will get a total sum of if any missing values are present in the data set. Okay, so right now it is coming like 0, so meaning like there are no missing values present in the data set. Now see that, to see the dimensions, this we have already seen, and to see the type of our data frame, here you can see like this one, all are taken like integer, and BMI coming as numeric, then diabetes pedigree function as numeric, outcome is also taken as integer here. Okay, this is how it is loaded automatically. If any changes we have to make, we have to specify that. Now if you do a summary of the DF, it is coming like this. Okay, so the minimum value, first quartile, median, mean, all this you have seen in the last lectures, so I don't think it's required now. Okay, so initially, so this is like, you can take it as like a case study. Okay, so this is like classify whether a person has diabetes or not depending on the data which is given for all these different columns. Okay, so first what you can do is, first you have to visualize the data which is coming. Okay, so for that I'll be giving different plots. So this particular thing, for each of the columns I'll be giving different plots. Okay, so ggplot I'll be doing, we have already seen what the ggplot looks like, but here what I'll be doing is data I'll be giving, then the aesthetic, AS means the aesthetic is changed according to the value of pregnancies, and then I am plotting a geom_histogram, means the plot I'll be doing is a histogram plot, then all the different values are given, and I'm adding as a density plot also. So just I will show how it looks like for the different values. So for A I am giving like pregnancies, then glucose. So for all the different columns I am giving in different variables like A, B, C, D, E, F, like that. Okay, so C, same things are given, E, F, G, H. So 8 columns are there. The 9th column is like the outcome, whether a patient is diabetic or not. So that is not taken. Now I am arranging all the different plots which I have given, like GG plot and histogram with density. Okay, then I am arranging that, and then what I am doing is like I am giving a GG arrange, and then I am plotting. So here you can see this particular plot here. So since I have done it like that, for each of the different columns I am doing a density plot with a histogram. Okay, so I have given geom underscore histogram, that's why the data has come as a histogram. Then I am putting the borders as red I have given, that's why border. Then fill also I have given as blue, that's why it's coming like this. So you can see the different distribution of the data. So separately we have taken. In earlier when we had seen the pair plots and all, so in pair plot it is like everything is congested to a single plot, and we will be seeing the relationships. Now so since I have labeled it differently, so here you can see A, B, C. This one I have arranged it as like number of rows equal to 3, number of columns equal to 3. I have arranged it using GG arrange, and I have plotted it, visualized it like this. So you can see for different columns this is the data coming. Now you can see here how the data looks like, how is the distribution, because this is a density plot also. So this one you can see that it is kind of right skewed. Okay, now this is kind of looking like normal distribution. Here also some distributions, but some outliers like that is there. So you can see the distribution of data in this particular plot. Now, so that is fine. Now this I have just included in case if you are getting some problem with this particular package. Okay, GGPUBR. So this is required for geom histogram for plotting that. So sometimes when you install this particular package the normal way, it will be raising some issues. So sometimes you have to go for other repository to download it. Okay, so that's why I have just mentioned it here. So now we have done like this. Again, just I am seeing the outcome. So this is like earlier we have seen the different features. Now I am seeing the outcome there. So this is like 0, outcome 0 and outcome 1. This is the distribution. So about 500. I'll just increase this one. So about 500 people are there who doesn't have diabetes, and about more than 250 to 270 like that people are having diabetes. So right now this particular warnings has come, like did you forget to specify a group aesthetic or to convert a numerical variable into a factor. So right now the data which we had given here is in the numeric form. So you can see that the outcome is numeric. Earlier when we had read some different kinds of data, what we had done is like we initially itself we had changed data as a factor, and in some other data sets it's already coming. For example, in the IRIS data set it was already coming like a factor. So here it was not taken automatically, or it was not given like a factor, or it was not given like a category, different categories. So what you have to do is you have to factor it, and you're factoring the particular column which is outcome. The levels are 0 and 1, and for 0 it is like negative. Negative means that the absence of diabetes, and positive means the presence of diabetes. So you are factoring it like that. Okay, now now if you look like DF is a factor with 2 levels, and one has been changed to positive, and the other one negative 0 has been changed as negative. Okay, so I think this is clear. Now what you can do is okay, good evening. So now what you're doing is you're selecting some features from this and forming a subset. Okay, and then you are just doing a box plot. Okay, So box plot I think you have seen earlier, right? No, RStudio is not provided for candidates. This is just for your understanding, okay? Because anyway you will be learning the theory first for all these things, and later you will be working with the different IDEs, right? So how many features in this data set? 8 features are there, right? Where is the DF? Right, yeah. Pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree, function, age. This many features. Now, so here right now we will be looking, so we have already seen the distribution with a histogram and density plot. Now we will be looking at a box plot. So this is the box plot. So visualization is very important in the initial stages of the analysis. Also, it's also important while giving the inferences also, but initially you have to check how your data is distributed. So right now you can see this is the box plot for the different variables, right? It's color coded according to the different variables. You can see that insulin has many different outliers, right? And these are the distributions. This is like the mean. The middle line will show you the mean or the median. Then the other things are the like the 25th quartile and the 75th quartile, 75th percentile of the data. Then these are like in box plot you will be saying it like the whiskers of the box plot, okay? And these are the different outlier values. So usually what you will be doing is like before you are doing your analysis you will be removing the outliers for the analysis, okay? So this is the box plot formed. Now another thing, you have to see the correlation, okay? So earlier someone has told from the scatter plot. So scatter plot, from the scatter plot you can just see the different distribution, that is right. But if you want to know the values you have to do a correlation plot, or you can just see the correlation also. So right now I am doing it as a plot, okay? So I am just giving the dimensions, just I am giving like 1 to 5, okay? So if you zoom it out right now, it's like for the first, so since this doesn't come in, since all the features doesn't come in a single picture, that's why I given 1 to 5, okay? Because just I will show you, like otherwise you have to reduce the figure size. So I have taken the first 5 features. So here you can see pregnancies, glucose, blood pressure, skin thickness and insulin. You can see the middle diagonals, they are having 1 values, but you can see that the other features are not having any higher values of correlations. So that means that in your analysis you don't have to eliminate any of the features. I mean, of course later for your analysis you will be looking at feature importance and all, and in feature importance you will be finding out that some features have more influence on your final analysis of the data. So in that some features you will be ignoring. So that is like finding out this feature importance scores and all. But before that, first you will be looking at whether you will be having any correlation between the features that you have taken. So here you can see that these all values are not having any high correlation. High correlation means like 0.8, 0.9 values like that. If you are having, then the columns are having some interdependency, okay? So that should be avoided. So right now in this particular data set there is no columns which are having higher correlation with any of the other columns, right? So you can directly include all the different data. So correlation you can use for that particular analysis also. So for some of the insights from the data is in these findings, whatever we have analyzed right now, the mean of the variables necessary to predict the variable pregnancies, all these things is greater than the median. So first I will show you the thing once again. So in this plot when we did, okay, so I have to run that once again. So okay, so you can see that I'll just come to the inferences. So you can see that here the median and mean are not same in most of the cases, right? It's not coming in the middle. The plot is not coming as a perfect normal shaped curve or a bell shaped curve like that. It's not coming. So one of the insight is that the mean of the variables necessary to predict the variables is greater than the median. Some of the case mean is higher than the median because the data seem to be biased to the right. Okay. Now other thing is our data's histogram and box plot support the conclusions of the summary which was taken. Then the correlation map shows that variables in our data do not have any strong correlation with one another. Is there any relationship between? Okay, that is a physiological question. So this particular data set I have shown, right? So I'll come back to the data set, Pima Indian diabetes data set, right? So this one is taken between for females. Okay, all the patients here are females of at least 21 years old of Pima Indian heritage. So in this particular data set, this is like taking some relation of the gestational diabetes mellitus also. So whether you are developing diabetes during pregnancy, because that is one of the cases where you will be developing. If you have the case where you have developed diabetes when you were pregnant for this particular females, then they have a higher chance of developing diabetes or type 2 diabetes later. So that particular relation is there. So because of that relation also, and this particular data set is also used for finding out whether a person has GDM or not, this gestational diabetes mellitus also or not. So that is why that particular feature has been included. So all these females, the number of pregnancies they had are taken. Okay, so it ranges from 0 to 3 actually, I think. Okay, no, not pregnant and 3 times pregnant, like that. Okay, so that is the data set feature. Okay, so there is a relationship. You are if you have developed diabetes during gestation period, then there is a higher chance of developing type 2 diabetes in your later stage. That is why. Okay, so that's why that has been included. It's a data set feature. So okay, so that is why. So these are the insights from the data set we are having. So that is why one thing, when you are applying for different data scientist jobs also, based on the area that you are applying for, based on the company you are applying for, you should have some idea about that particular area. Okay, that company. Because if you are applying for a data scientist position in any of the biomedical companies, then you should have some idea about that also, not just the algorithm part. You should develop some idea, okay, and have an interest in that. If you are applying in any finance area, then you should have the technical acumen about that particular field. Okay, so it varies. That's why every different companies are asking for data scientists. Okay, so now what we'll doing is that for our particular analysis we need a split of the data, like train and test. So this is another way. So cutoff, create data partition according to the outcome column, and I'm giving like 0.85, like 85%, right? And list equal to false I'm giving. Will any questions related to data set be asked in the final exam? Data set, you can have find questions maybe like given a distribution of the data and ask whether the mean or median is right, or some data about how the distribution looks like. Some kind of data can come like that, not anything about the data set which is given. Okay, how the data distribution looks like, that all data can, that all questions can come. Already in your assignments also it had come once, I think. So not anything about the particular data set. Okay, now so you are giving it like you are finding the cutoff integers matrix, and using that cutoff you are removing the values where it is coming and giving as test df, and the remaining 85% as train. Now again we are setting the random function values. Here are different values given. Now I'm giving for a tenfold, going for a tenfold cross validation. So cross validation I think you have already seen in the previous lectures, right? So here the whole data, the train data, will be converted to 10 sets, and in one time one set will be kept as for validation and the other will be taken for like train. Then the next set will be taken and the other 9. So you already have seen cross validation in the earlier lecture. So I am giving a cross validation value, okay, cross validation, and I am giving like 10, so tenfold cross validation. Then I am doing that, I am specifying the metric. Final exam, that I am not very sure. You might not, usually you won't have to write a full program or anything. I don't think you'll be having, but I'm not sure anyway. But sometimes you can be asked on how to change a particular, find a particular detail. For example, earlier within sum of squares, if you want to find out, maybe you have to see the particular thing. Like if your model is given like this, maybe like total sum of squares, how to find out like that, sometimes you have to do. And sometimes maybe you can like expect like whether how to have a particular arrangement of particular data. Sometimes you can have like that, but in companies and all, usually in interviews and all, they don't place so much importance on the syntax of a particular program. Okay, they don't put that much importance, only your thinking capability as well as how you look at the different problems and how you understand the algorithm. Okay, you need to know how to program it, but they are not very particular on the syntax. So here also maybe not a whole program, but sometimes you can expect that, since an essay level thing you have to type. Okay, if I want to Rohit, it is there in that same link. Every week it is present. Okay, in the link. Okay, just I will put that. Okay, I'll paste the whole link of both the TAs. Okay, because there is yes I'll just post it. So in this particular link, both the TAs data as well as all the lecture videos taken by both of us and our folder links are present. Okay, so I think it's there, right? Is it accessible for you? Rohit, you can give just a confirmation if it's accessible. Okay, yeah. So what can we do? Like we have given the metric also, like accuracy. So what we'll be doing, we'll be training the model, the formula there, outcome with all the different columns which are present. Then data has to be taken from the data. Okay, so right now I have given this one as train df. Okay, train df, sorry. Okay, so what I'm doing is, like, sometimes some NA values will be coming, so I'll be doing like this, data equal to data itself I did. Okay, so data is the function yeah, you have got it right. Okay, so data is the argument there in that particular train. So data equal to, I'm changing that data as na dot omit of train df. So any na values are still there in the training set, it will be omitted, because when you are training, if there are some missing values, it will be taken into account, so it won't be producing a result. So we are avoiding that. Okay, now I am doing the model. Okay, and it has trained, and we'll see how the model looks like. Just wait a moment. Okay, so many people are still joining. Okay, so the model looks like this. Okay, so the things which you have already seen, like that, here also it will be similar. The kernel, I have told you, there are different kernels there. Later you can check the whole theory behind it. So right now I have using a radial basis function. Earlier we have just seen linear only in the examples that we had seen. So radial basis function kernel we are using here, and right now, since I have used an 85% train set, this much samples are present with 8 predictors and 2 classes. Okay, now all the summary values for the different folds, and then the final tuning parameters present. So these are all parameters of the particular classifier. Okay, now model summary, and we'll plot the model. So this is what the model looks like for the different cross validation and the accuracy and the cost function. And what we can do is, so right now we have trained with the trained data. Now we will be applying that particular model in the particular test data. So we'll predict like that, and the confusion matrix also will be there. So confusion matrix, this is the usual function confusion matrix that we have seen in the previous lectures itself. So here the reference as well as the prediction, negative values and positive values. Here you can see the diagonals represent true, here true negative as well as true positive here, because negative positive, this is like that. And the accuracy has only come up to 73% only with the current values that we have given here. Okay, now later we have to do so many changes in the data analysis, and in this particular different set of data also many things are having less feature importance. So in that particular case, like there are different ways by which you can select the features, that is known as feature engineering. Okay, selecting the relevant features for your training, and after feature engineering you can do the training that will increase your accuracy. Okay, then there are other methods by which you can sample. So right now you can see that the outcome, one plot that we have done, seeing how the outcome looked, right, like this one only, I think. So when we had plotted this, sorry, yeah, this one. So I think I have to load that once again. the plot is being removed. Okay, it'll take time. Okay, so you had seen that in another earlier plot you had got like outcome different values, like you have seen that about 400 of that were having negative values and about 270 was having positive values. So what you can do is you can sample that particular thing is known as like upsampling, like oversample or undersampling. Okay, so undersampling is like making both your classes like equal to the lower number of classes present. So for example, right now if the number of positive cases are like 270, then you'll be making the negative also like 270 numbers. Okay, then oversampling methods, so that is like commonly grouped under resampling method. So there are different ways by which you can resample it. So if you do the other thing, oversampling methods, then it will be like your lower number of the class which is having less number of entries will be sampled up to the number with the majority class. Okay, so minority class will be taken and given as the majority class number. So all these things will help you to improve the accuracy. So there are many methods which you can do. So right now your accuracy was coming like this much only, 73%. So it has to be improved. Okay, now I think that it's taking time to remove it, so it has hanged up a bit. So just wait a moment. Okay, so that is the SVM. We have seen till the final thing. Okay, so that is support vector machine. Then another thing that we can look at is decision tree, that also we have seen. So just I will go to that particular site also first. So here you can see decision tree in R programming. Types of decision trees are there. So this is the basic thing that which have been shown earlier. Now usually right now we will be using CART. Actually this is the classification and regression trees. This is normally used right now. There are many other methods also. So how to do that and the different ways by which you can select the tree is given here. Right now you can read through that. So last class I have just explained how you will be seeing the different classifications or the different trees, how you will be taking the values. So for this particular thing we will require all these data sets. I am loading all the data sets. Okay, now for this particular data I'll be looking at this particular data. Okay, data of reading skills, it's already there in the RStudio. So this is the particular data, reading skills. So native speaker, yes or no, the age, shoe size and score. So this is a data set which doesn't show that much information, give that much information, but it has 200 entries and 4 total columns. This is the label, whether that person is a native speaker or not. Okay, so and the score is given. So the sample data will split according to 80% train set and 20% test set. So this is the normal sampling thing, and we are using a decision tree. So decision tree is implemented with C tree, and the data, this one is our target column or the dependent column, native speaker, that is a categorical column, and formula is given with respect to all other columns, and in the train data we are plotting the model. So you can see the model here right now. So first what they will do is, like in the first tree we are getting the probability, I mean seeing the p-value less than 0.001, and the score like this, it has divided like 43.346 or greater than 43.346. So first you are differentiating with respect to the score, and then later you are in the next step you are seeing the shoe size. Again the tree has come up to like score again considered, then age. So this is how the tree proceeds, the decision tree proceeds. Okay, here you can see when the age value, it is like 9, okay, greater than 9, and 9 value only one observation was there, that's why the tree is terminated at that particular node. Okay, so this is how the tree looks like. This is how the tree has been formed for the particular number of function arguments that we have given. Okay, so we haven't given any special arguments like number of trees or number of estimators. We haven't specified anything. If we are specifying, it will be changed according to that. So right now all the default values were taken, so we have plotted the model. Now using that particular model we'll be predicting in the test data, and this particular table will be forming the confusion matrix there. So predict model is here, and the test underscore data $native speaker, which will give you the target column and mapped. So right now here predict model, this is the true classified things, and true negative and true positive, and these are the misclassifications. So accuracy, how can you do it? So accuracy, either you can find out the misclassification and then 1 minus misclassification rate, or another way is like you can find out the sum of the diagonal matrix, sum of the diagonal elements by the total number of elements, sum of the total number of elements. So that will give you the accuracy. So accuracy for this particular test is found to be 0.86. Yeah, 43/50. Yes. Okay, so this is decision tree, and I think if you have any other doubts you can ask, otherwise we'll stop with the session. Assignment 3, okay, just I will check. Assignment number 3, maybe probably it will be week 3, right? This one? Oh, sorry.
Madam, the dice problem.
Once more, can you tell me?
It is regarding rolling up dice. With my main assignment, it was problem 1 and 2, assignment number 3.
Oh, is it present assignment?
No, not in your that is in that NPTEL course. The third assignment is the original assignment. Third is 1 and 2.
Okay, since like we are not instructed to give the present assignment, I haven't.
No, I am telling assignment 3, madam.
Yes, assignment 3 itself. Like we are not asked to solve the solution for the present assignments actually. Just
no, you can throw some light how to solve, madam.
Assignment 3 you are telling?
Yes, ma'am.
In your present one, okay, just let me just check. I think you have got the solutions for this, right?
No, I am not how to work out. I am not getting some problem, madam. I am not getting the answer.
So, like, just I will see that.
Yes. 1 and 2.
1 and 2 is so this is like P of A given B type of problem, right?
Yes, ma'am.
Yeah, so first you have to see wait, assignment 3 question 1 answer should be 0.93. So Swami, since we haven't looked at the present things, okay, yeah, I will recheck. I haven't looked at these questions. Assignment 3, right? Okay, I will check once again and solve. So first you have to find out the x values less than 5. So it's like 6 die mark like 1 on one face, then 2 on the 2 of its faces, and 3, right? So anyway, instead of 1 2 3 4 5 6, you are getting 1 2 2 3 3 3, right? So then you are having two throws also, so you have to find out all the different permutations like you can do like these in these two throws, right? Like 1, it can come like 1 1 2 1 thing like that. So in all these, the x value less than 5 you have to take first, that probability, and then given that you have to see whether it is like greater than 2.5. okay, so right now I think it's a what's the problem? Maybe the answer is coming like 0.93. that is the problem for you. Are you also getting the answer 0.93?
No, madam. I'm getting something less than that.
Okay, what I'll do is like, I mean, this is a straight away problem only, but
Actually, the total number of events is 36. No?
0.88 I got. It's okay. What I'll do is like, I'll solve this and I'll put this in the drive. Okay.
Okay.
Yeah. Question 9. What is question 9? This I think I might have told, right? Rohit, this was in the assignment. Just I'll see. What is the answer for that one? What is your problem with that question, Rohit? Question 9, this I've already solved it. Okay, it's not in the option. Just see this one. I think I'd already solved it earlier. The same question, right? Is this the same question? Can anyone else clarify? Yes. Answer is 0.0455, right? Just wait. What is the answer given? C. Okay. This also I will check. Okay. Or is there any changes in the values? Yeah, it's similar only. Okay, Natarajan, what you are getting the value? I mean, this is what that was present there in the previous course also, so it might be wrong actually. Okay, anyway, I'll clarify it and I'll put this question also. Natarajan, you are getting the answer as 0.0455. Are you getting like that?
0.0275.
You're getting 0.0275.
If I do like this, 0.55 into 0.05, both
Okay.
probabilities by multiply, I'm getting that answer.
Okay. What is the probability that it is from supplier X? Okay, but that might not be true. Anyway, this also I'll check once more. Okay. So these two questions, right? 1, 2 and 9. Anything else? Week 4, wait. Week 4. This is your present assignment? Is this your present assignment? Question 1. This one you mean? Question 1 of week 4. Okay. Okay. Interval was not mentioned. But okay, do you need that? First, if you differentiate, you'll be getting the points, right? Okay. So in this kind of questions, you can just check the options and do your things accordingly. Rohit, I think you have left the meeting, or? Yeah, tell me. No, what can you tell me the steps to do for that particular thing? That's why you can just look at the options for that particular thing. Okay, you can check the options, and whichever is coming closer you can select. In case if a particular function is having many minimums, maximums like that, anything is there, you can just look at the option, and whichever is coming closer, that you can select. Is that fine? I think the solution also has come. Wait. No, anyway, the closer answer will be in the options, okay, that you can see. 7th, week 7, present assignment. This is already, our submission is over, right? Assignment 7, otherwise I won't be able to discuss that. Yeah, so 7th, 10th question. Okay, 10th. This is the 10th question. Srinadi. Okay, what 10th question? What is the problem with this one? Just an interpretation, right? Okay. So in here you are given the distribution between the sepal length as well as sepal width. Okay, yeah, here so the different classes are given. So this is the iris data set that we are talking about. So 3 classes are there: Setosa, Versicolor and Virginica. All has been marked in the 3 different colors here. So first statement first we'll check right now. Sepal widths of versicolor flowers are lesser than 3 centimeter. So sepal width you see, and 3 is right now here. So versicolor is marked as green, right? So you can't say that, right? Because it is going above 3 centimeter also. So you can't say that sepal width of versicolor flowers are less than 3 centimeter. Then next one, sepal length. Sepal length is in this axis of setosa flowers marked by red. So they are lesser than 6 centimeters. So the 6 centimeter line is here. So anyway it is lesser than that. That is why that particular answer you can take. And then the third one, sepal length of virginica flowers are greater than 6. So virginica, where it is blue color, so sepal length greater than 6, but some are coming in the lesser than 6 area also. So okay, that's not needed. And sepals of setosa flowers are relatively more wider than versicolor. So versicolor and setosa. Sepal width you have to see. So setosa sepal width is more than versicolor, it is directly can be seen. So that also is a correct option. That's why these 2 options are coming. Okay. Now assignment, I think that's clear. Then assignment 7 is this one only, right? So assignment 7, question 7. This is Swami, this one. What can you comment? Is this the question? Okay, what can you comment on distribution of independent variables in the data frame iris? Okay, that we'll go with RStudio then. I think this one only. Sorry, not Visual Studio. RStudio. Okay, so this one, just let me see this one. Yeah. Okay, not. Actually, you have to see the distribution of that particular data, right? So what can I do for that? Okay, this one itself we will see. Okay, first what you can do is that you can see, or so this particular question I think I have solved it also. So we will see that then so right now the plot has come. So what was the question? So the question was comment on the distribution, right? Not normally. So here, okay, look at this Swami and tell me which is normally distributed. You can answer in the chat window also.
First and second.
First and second are showing kind of, yeah, normal. Okay. Yes. So the one is not showing that much normal distribution. It's little skewed, right? But anyway, you can give like similar. It looks like. So in your question, first option was variable sepal length and sepal width are not normally distributed. That's wrong, because sepal width at least is very much normally distributed. Then the next one, all variables are normally distributed. It's not true. Okay, not normally distributed. Then variable petal length alone is normally distributed. That also is not true. None of the above also you can't say. So here there is the problem of all the variables are normally distributed. So that is an error. Okay, Swami?
D should.
Yeah.
D is correct answer, no?
Yeah, you can give it like none of the above. Another way to find it out, in the previous section also I think I have told it, like you see the distribution. Okay, can we get marks? Anyway, it will be, you will be getting that. Okay, just raise that comment in the discussion form. They'll be clarifying it and correcting it. Okay, you raised so just wait for some time. It will take time, maybe. Not getting. Okay, anyway, the answer will be like none of the above, because in the earlier course there was another option there which suited to the answer. Anyway, don't worry about that, because it doesn't add to your final marks, right, for the final exam. Yeah. Okay, so there is another method like you can see the distribution also, the mean and median values. If your mean and median values are closer, then also you can say that the distribution is normally distributed. Okay, that is also another way, Swami. Yeah. Then assignment marks are added. Is it added? Okay, then I'll try to talk okay. Yeah, anyway, I think they'll be raising the clarification, so yeah. Okay, maybe it will be changed. Okay, in assignment 7 question 9, L apply and S apply. S apply, this time there are many. Okay, okay, that is also a problem. So wait, so yeah, Srinadi, that is, you are also right. So earlier in the question that I had discussed, I have told 2, you'll be feeling that it is like true for giving the number of columns. Okay, but in S apply the syntax is different. Here it's given S apply, iris data, all those things are same. It's given 2 comma mean. It should have been like S apply, iris data, this one particular thing is there, comma mean only should have come. You can check the earlier video also, or just I'll run up to this one, and just I will show you this one. Okay, S apply. If I run this, error 2 is not a function, character or symbol will come. The correct syntax will be to avoid that particular instruction, like 2. Okay, so you'll be getting an answer. Anyone else? Any other question? Swami, are you trying to speak something? Okay, yeah. So any other doubts? The other things I'll be solving and checking the solutions. Okay, so if you are getting different answers, then I'll be posting it later on the Google Drive. You can check. Okay, I'll be keeping it in a different folder. The very complex things won't be coming. Okay, without RStudio, where if it's difficult to calculate, that you won't be getting. Mostly the problems will be like what you have seen in the assignments, which doesn't have to do much with RStudio. In previous year papers, I don't have that access to that. Okay, Rohit. Type of questions which would be asked, that I'm not sure if they will be scheduling, right, Hariom? Because usually it's for 8 weeks till now. Sometimes they'll be telling that. We'll have to see. You'll be getting mail anyway if they are scheduling. Most questions from linear algebra and probability, yes, but like I said, you can have something like shown like distribution, how it looks like, then how is the confusion matrix, how to calculate the different performance metrics like accuracy, misclassification, sensitivity, specificity. All those things also can be asked. Okay, sessions, yeah, it can be scheduled. If it's scheduled, you'll be getting that mail. Okay, like every time you'll be getting a mail, right? If it is there, you can come to the same Google Meet link. In the same link only I'll be doing, same time. Oh yeah, it can be done. Let's see next week. Anyway, if it's there, it will be the same link. Okay, and at the same time you can come. Hariom, is that clear? There are multiple choice questions, so in that you can expect that. Yeah. Okay. So I think there are no more questions.